Hello dear students, today we're gonna study a new topic, but before we start this new topic we have to revise some measurements. So in this case we will talk about volume and pressure. So we have to remember that 1 liter is equal to 0.001 cubic meters, that is 10 to the power of minus 3, and 1 atmosphere is equal to 100,000 pascals, or 10 to the power of 5 pascals. And here we have the term that is called change in volume. Change in volume is basically V final minus V initial. Okay, so you have to remember these terms when we will study this topic. So today's topic is called work in a thermodynamic process. From the previous lesson, I think you remember what is a mechanical work. So we are going to go into details right now. So this is the formula that we're gonna work today. So here we have W, this is work, and here on the right side we have pressure and delta V. So pressure it is the pressure of the gas, and delta V here it is increase in the volume. Okay, so when the piston here moves up, it moves up to this level, the volume of this gas increases. Okay, and the change in volume delta V times pressure will be equal to work. Okay, while here we have to know that pressure is held constant, so the pressure does not change. Okay, the gas does work as it pushes the piston. So let's solve one problem to completely understand this one. So a gas sample expands from 3 liters to 8 liters against standard atmospheric pressure. What is the work done by the gas? So here the pressure is atmospheric pressure, which is equal to 1 atmosphere, which is equal to 10 to the power of 5 pascals. And also here we have the information that gas expands, so the pressure increases. This is our V final, this is our V initial. So V final minus V initial, which is our delta V, here is equal to what? 8 minus 3, 5 liters. Okay, 5 liters. And the thing here in volume, we have to convert this into cubic meters. So 5 liters will be equal to 5 times 10 to the power of minus 3 cubic meters. So when we have pressure in the pascals in the pressure and cubic meters in the volume, we can just multiply it. So by the formula, work equals to P delta V. So we just substitute the numbers, 10 to the power of 5 times 5 times 10 to the power of minus 3. So here minus 3 and 5, they give 2. So we have finally 5 times 10 to the power of 2 joules, which is equal to 500 joules. Okay, that's it. The next problem, a gas in a closed container absorbs 450 joules of heat. What is the internal energy? So here we have T. What is the internal energy of internal energy change of the gas? So here we have to remember the formula from the previous lesson. Q equals to delta U plus W. And here if we open this W, we will have delta U plus P delta V. Okay, and as it says here, this is a closed container, so container which is closed and which does not change its volume. Okay, so here volume is kept constant and delta V will be equal to 0. That's why here, if this is equal to 0, so 0 times any number will give us 0. Okay, so just simply Q will be equal to delta U. So as the gas absorbs 450 joules of heat, so we have plus 450, so delta U will be equal to just plus 450 joules. Okay, so this is just an information. So you have to understand that if the container is closed, it means that its volume doesn't change and delta V is equal to 0.